Now, we shall continue to discuss the measurement of pressure. Now, measurement of pressure was first understood and explained by Torricelli, who lived between 1608 to 1647 and who created a barometer, which is a device used for measuring the atmospheric pressure, or that is also known as a barometer pressure, or it is also known as a Torricelli pressure to honor him. He developed in the year approximately 1643 to 1644. So, it means around 365 years ago. He observed and measured the atmospheric pressure, right. So, we have a small animation here. In this animation, we have a tube which is closed at one end and this is open at one end. We have a container here. In this container, we have a mercury, and this tube is also filled with mercury, and it is inverted inside a mercury, and so we get this much height. Look at this animation. We have a tube open at one end, closed at another end. We have a container filled with mercury, tube is filled with mercury, and then it is inverted inside a mercury. Then we get a mercury column in a tube. These are the original, look at this figure, these are the original Torricelli sketch for measuring the atmospheric pressure. Now, we have a third figure also to understand that how barometric pressure or atmospheric pressure is measured. So, we have a tube which is closed here and this is open here. This atmospheric pressure is applied at this surface which is open. This pressure is atmospheric pressure naturally. This atmospheric pressure is being applied here. Now, this atmospheric pressure is applied here. So, at this point which is situated on the same horizontal line, the pressure will be atmospheric, and as we go upward, then pressure is continuously reducing, and at this point A, this A point, what kind of pressure exerted? This pressure is exerted by the molecules which are available in this portion. Now, this end is closed and this was initially filled with mercury and this tube was inverted. So, that is why some of the molecule or mercury, this has come down. So, it means that here we have molecules of mercury, and we know that vapor pressure of mercury is very less, because mercury has very low tendency of evaporation. If mercury has low tendency of evaporation, then it will exert very low vapor pressure, right. So, with the help of this figure, we can understand that how atmospheric pressure can be measured with the help of this column of mercury. So, with the help of the knowledge of the fluid pressure equation, we can write the equation which will give us the pressure in the form of height of the mercury available in the container. So, how do we write equation? Pressure at this point and pressure at this point is same, and at this point what is the pressure in terms of height of the fluid? At this point the pressure is equal to gamma into H. Gamma is the weight density of mercury into height of this column. So, P atmospheric, this is P atmospheric which is same at this point horizontal, is equal to gamma into H, this much pressure exerted by this column, plus pressure exerted by this vapor. So, gamma H plus P vapor. Now, P vapor of mercury is very less, so it tends to 0. So, P atmospheric is equal to gamma into H. So, here you can see the value of P vapor is given here, which is very less. So, it is neglected. So, P atmospheric is equal to gamma into H. So, in this manner we can calculate the atmospheric pressure with the help of height of the fluid, which can be measured in this device and multiplied by weight density of the fluid.